Alright, today we are going to take a look at adding rational expressions. Right? Adding rational expressions. So, to add rational expressions, okay, these are just fractions. So, what do I need to add fractions together? What's the first thing I need to make sure that I have? I mean, you do need eyeballs.
You don't, not necessarily, you need an umbrella.
Yeah. Okay. Yeah. Well, what do we? This.
One thing I mean, I think it was like her nanny just kind of like grabbed her one day and started like putting her hand.
I'm sitting here and I can't see her. I'm just figure it out. I don't know it.
Yeah, I mean, that would be a scary life.
Mine would definitely
How am I
never born.
Unfortunately, definitely.
Or how do we do it? Alright, to add fractions together, we need to get common denominators. We need to get common denominators. So, the first thing that we have to do is make sure we have common denominators. On this first example, 25m cubed, 25m cubed. I do already have common denominators. So when I'm adding fractions together, once I have common denominators, I just add the numerators together. In this case, that would mean combining like terms in the numerators, right? So what are my like terms? How would I add these two numerators together? Yeah, m plus m would be 2m, and 2n plus 4n would be 6n. Okay, now my denominator stays the same. Okay, that's a common mistake that I see at the beginning of things like this. People want to add the denominators together as well. You do not add the denominators together. The denominator stays exactly the same. So my answer here would just be 2m plus 6n over 25m cubed. That's it.
That's your answer?
That's the answer.
Seems to be true.
Okay, so, I mean, in these ones, we already had common denominators. Right? So, again, I already have a common denominator of 10a. So, all I need to do is add the numerators together. So, go ahead and take a couple of seconds and try this one here. Did we get 11a plus 2b over 10a?
Oh, I did.
5a plus 6a is 11a, negative 3b plus 5b is 2b. Alright. Now, let's take a look at some examples where we do not already have common denominators. Okay, so here I've got 6 over 4 plus 3x over 4x. I actually have a couple of options here. I think the easiest would be to maybe simplify before we add. So if I take a look at this 3x over 4x, how can I simplify that? The x's, right? The x's would cancel out. And I just end up with 6 over 4 plus 3 over 4. Now I do have common denominators, right? So now I can just add the numerators together. And I would get 9 over 4. Okay. Yep. Yes. Aileen Marie Miller. Mr. Clark wants to see you. You're not in trouble. So he
Oh,
wants to
you're
see
in
you.
trouble?
He said your full name.
Oh.
You are in trouble. He said
Well, full names are both
that's
Aileen Miller.
that's what I know.
All right, we okay with this one? All right, let's take a look at the next one. 5n over 4m plus 5n over 5. Well, we can't add the numerators yet because I don't have common denominators. The last one we just did. Yeah. All right. So, is there any simplifying I can do before I add these together? Yeah. Right. I've got 5 over 5 over here. Right. So I could cancel out those 5s and just make this. Well, no. So it'll be 5n over 4m plus just n over 1. But now I still need to get common denominators, right? Like in the last problem, canceling things out got me common denominators. In this case, it does not. I've got 4m as my denominator over here, and 1 is my denominator over here. Those are definitely not the same. To get common denominators then, okay, the easiest thing to do is look at all the factors down here. Okay, here I've got 4m, here I've got 1. In order to make the denominators the same, I'm just going to multiply this by 1 over 1. And then over here, I'm going to multiply this by 4m over 4m. So I took this, all the factors in this denominator, and multiplied top and bottom by 4m over here. And I took the factors in this denominator, which is 1, and multiplied top and bottom over here by those factors. Okay? Now, why am I allowed to do that? Why am I allowed to multiply this by 4m over 4m? Because I said so. Because I can just make up the rules that I want. I mean that's why we're doing it. Yeah, to get a common denominator. But why is that allowed? Why can't I just multiply this by 4m over 4m? I mean, that seems like that's going to change a lot. So yeah, I mean that's why we're doing it, to get the 4m in the denominator over here. But why is this allowed? Why is this a mathematically legal operation? Yeah, because we're multiplying both the top and the bottom by the same thing. So 4m over 4m is just 1, right? Anything over itself, bless you, anything over itself is just equal to 1. So if I multiply something by 1, that does not change its value. Okay, even though this is a weird looking 1, 4m over 4m is still just equal to 1. Crazy. Right? So I'm allowed to do that. I'm allowed to multiply anything by 1. That doesn't change the value. This is 1. So what we get then is still 5n over 4n plus 4mn over 4m. Now I do have common denominators. Now I can add my numerators. So how would I do that? Can I smash these into one term and make this like 9mn squared or something like that? What you said?
No.
You just be like,
Well, so if I
Wait,
cancel out
you
these
cancel-
4m's, I would be back up to here and I would not have common denominators.
can you cancel that instead?
So when we're adding things together, we can only combine them if they are like terms. What does it mean to be a like term? Yeah, they have to have the exact same variable. These two things do not have the same variable, right? This has n and this has mn. So these are not like terms. I cannot combine them.
It's funny because they're all the same. It's almost simplified. 4m itself, and they all be 1. The denominator should be 1. So, big deal there.
How? Well, we couldn't simplify this one. No, yeah, because we got 5n over 4m. So I wouldn't be able to do anything with that one. So once I have my common denominators, I'm just adding the numerators, and these are not like terms. So I can just write this as 5n plus 4mn over 4n. Now, I cannot simplify this any further. Okay? Some people would be tempted to cancel out these 4m's, but since I'm adding in the numerator, I can't do that. I can only cancel things out when I'm multiplying. Okay? I can only cancel out factors. Here, these are not factors. These are not being multiplied together. They're being added. So I cannot cancel those out. That's my answer. Good.
Good job.
Any questions?
Yeah, when is it going to get hard? I mean, it's already hard, but harder. Because I know it's going to happen.
I mean, the hardest ones that we'll look at are
Right here.
Is it a lot harder?
Yeah.
Yeah.
It's just gonna be more work.
Alright, so here, in our next example, I've got 4 over 3y plus 6y over 3y cubed. What can I do here? Cube the left side? Well, so yeah, so the only thing that I'm allowed to do is that multiply by one thing. Okay, I think if you had Mr. Haynes, or I think even Miss Bryan, Mrs. Frazee, called it a fancy one,
Yes.
right? That's what we're doing now. We're using that fancy one. Okay, fancy one. So the only thing I'm allowed to do is multiply each of these fractions by the same thing over the same thing. And my goal in doing that is to get the denominators to be the same. So over here I've got 3y, over here I've got 3y cubed. What should I do first here? We actually have a couple of options. So that is one of the options. If we look at this second fraction, I've got 6y over 3y cubed. Both the numerator and denominator have a y. I could get rid of one of those y's. Okay? So I can make this 4 over 3y plus 6 over 3y squared. Okay. So now my denominators are even closer to being the same. Right? I've got 3y and 3y squared. What could I do to make my denominators the same now? Okay, just multiply this one by y over y. Okay. Then I would have 3y squared down here. So, in our last example, we ended up multiplying the entire denominator over the entire denominator, same thing over here. That's always an option, right? We could actually do that in this problem. We would just have more simplifying to do at the end then. But we can make it a little bit easier on ourselves if we just use a little bit of common sense and just look at my denominators and say, well, this is 3 times y, this is 3 times y times y. The only difference is this one needs a y. So I can multiply this one by y over y, and I would have common denominators then. So if I do that, I've got 4y over 3y squared plus 6 over 3y squared. I now have common denominators. I can add my numerators. So what do I get? 10y? Right, these are not like terms. Okay? In order for them to be like terms, they have to have the exact same variable. So I can't combine these at all. This would just be 4y plus 6 over 3y squared. Okay. We okay with this one? Alright. Okay, so what if you have questions, ask questions. What doesn't make sense? Okay. So in this one I've got 4n over 4 plus 3 over 3n. So, yeah, and over here, I've got 3 over 3. I can cancel those out, right? And I also have 4 over 4 in this one. I could cancel those out. So over here, I would be left with n over 1. And over here, I would have 1 over m.
That's Mr. Moore for Valentine's Day. You got one.
Thank you.
Yeah. Oh. Oh. You got one.
Extra magic.
So, now what?
N over M.
Multiply that and
So I need to get common denominators, right? So on the left side, right, I would do m over here. And then over here, I could do times 1 over 1. So I end up with mn over m plus 1 over m. It doesn't matter. Well, so here, we just said to get common denominators, the only factors I have in the denominator are 1 and m. Yeah, exactly. I'm allowed to do this because m over m is just equal to 1. No. We have to have the multiplying by the same thing over the same thing. Alright, so now what?
That's it, man.
Right. I can just add my numerators together now, and there are no like terms. So I would just have mn plus 1 over m. I think better than Subway. Subway cookies. I really like Subway cookies. I don't know.
I think he's doing it busy from a.
Yeah, so let's take a look at the next one here. Alright. This one looks a little bit different. Right? I've got some subtraction now in my numerator and denominator. The process is going to be exactly the same though. I want to look at my two fractions, see if I can simplify anything. I cannot. So I want to get common denominators now. To get common denominators, over here, the factor I'm missing in the denominator is n minus 2. So what I want to do is multiply the top and the bottom by n minus 2 over here. The factor that I'm missing in the denominator over here is 5. So I want to multiply by 5 over 5 over here. So, we want to do the same thing. We want to multiply out the numerators and add them together. How do I do n minus 2 times n minus 1? Yeah, we're doing foiling or double distribution. Right? You may have heard either of those terms. So I need to multiply every term by every term. Right? So start with n times n squared, n times negative 1, minus n, negative 2 times n, minus 2n, and negative 2 times negative 1, plus 2. Then my denominator, we can just leave the denominator factors to show that we have collected all of these factors. No, this one. I mean, most of the ones that we look at will not X factor. Yeah, so I can make this look even a little bit nicer, right? I've got like terms right here, negative n minus 2n. So what would that get me? Negative 3n. So I'm just gonna erase that and write minus 3n. Right? Now in my second fraction, the numerator is a little bit easier. I just have 4 times 5 over here. So this would be 20 over 5 times n minus 2. Now I have common denominators. Yeah, so now I can combine like terms, and the only like terms are the 2 and the 20. So I would end up with n squared minus 3n plus 22 over 5 times n minus 2.
What is that plus in the numerator?
Yeah, those are the only like terms. So
Do we have to do it now, or is it later?
this one will not factor.
I just have like the
Wait, say that again. Two numbers that multiply to 22 that add to negative 4.
No, I'm not about like this.
But if it is a problem like this, is that at some point?
Just give it to us, Batch. Yes.
I don't know yet.
Smith,
No.
you thought I was going to say that.
Thumbs down. I disagree with that.
You disagree with me not knowing?
Yeah. Say no.
What's up?
Sure.
Alright.
Is it okay if it's like 5n minus 10? Does that have to be 5 parentheses n?
Oh, we got that.
Yeah, you can write it as 5n minus 10. Alright, any questions on this one? Yeah, it's done. Because we cannot factor this.
But you can factor the other.
Well, but that doesn't do us any good, right? Because then we can't add that to the 20. My goal is to combine these first. Alright, let's take a look at number 8 here. So that's a good first option here, okay?
Wait, and then can you just
We could, but for the 99% of the time, we want to, if we see something factored, we want to leave it factored, right? So Glenna said, let's cancel out the v's over here. So we just have 5 over 3 plus 5v plus 1 over 3 times v plus 3. Okay, that's a great first step. So now if I look at my denominators, I have 3 and 3 times v plus 3. I need a v plus 3 over here, right? So I can multiply top and bottom by v plus 3. So what will I get? My numerator here. 5v plus 15, right? We're distributing that 5 to both of those pieces. So 5 times v is 5v, 5 times 3 is 15. Alright, we can just leave that as v plus 3 times v plus 3. So then this second fraction won't change. Right? I already had 3 times v plus 3 in the denominator. So now I can just combine my like terms in the numerator. Numerator. So what will I get? 10v plus 16. 5v plus 5v is 10v, 15 plus 1 is 16, over 3 times v plus 3. Now, if you did not recognize that you could cancel out the v's at the beginning, that's okay. You would just have a little bit more simplifying to do at the end then. Okay? So up here we could have said, well, I need to multiply this by v plus 3 over v plus 3, and then I also need to multiply this by v over v. Okay? Then when we get down to here, we would just have a little bit more simplifying. Okay? So there are multiple ways that we can start these problems, right, that are correct. Questions on this one? All right, let's take a look at this one. So I've got 4r over 3r plus 5 over 3r times r plus 6. So on this one, we could, right. Yeah, so this one is a little bit tricky to look at first, because right off the bat it looks like, well, I should cancel out these r's, right? But if I look at the denominator over here, well, there's a 3r in this denominator, and I can't cancel r out with anything. So I need that r in the denominator. The only thing that I'm missing here is an r plus 6 over here. Okay, so what I could do is multiply the top and the bottom by r plus 6, and then I would get my common denominators. So I would, 4r times r would be 4r squared, and 4r times 6 would be 24r. Over, and again, we can just leave the denominator factored. So I'll just leave this as 3r times r plus 6.
You ran a bulk factor, not wrong.
Right, yeah, you can multiply out the denominator. You could write it as 3r squared plus 18r, that's fine. But you don't have to. Last one. Okay, so now I already have that denominator here. 3 times r plus 6. So now I can add my numerators. 4r squared plus 24r plus 5, right? There were no like terms that I could combine. And then that will all be over 3r times r plus 6. Okay. Questions? Stretches? All right, let's do one more together here, and then I'll have you guys try some. Okay, so on number 10 here, we've got 6 over 2p plus p minus 4 over 3 times 3p plus 4. Is there anything I can do before I start trying to get common denominators? I could simplify the 6 over the 2, right? 6 over 2 would just reduce to 3 over 1, right? So this would just be the same as 3 over 1p, or 3 over p, plus p minus 4 over 3 times 3p plus 4.
It really matters.
So yeah, if we did that at the end, we would be able to cancel out a 2 at the end. So it's wherever you want to cancel out a 2. So now if I look at my denominators, I've got a lot of different factors, right? I've got a p, a 3, and a 3p plus 4. Exactly. So I'm going to multiply this fraction by both of these factors, right? 3 times 3p plus 4 over 3 times 3p plus 4. And then over here, I'll be multiplying by p over p. So how do I do that multiplication then? I've got 3 times 3p plus 4 times 3. What do I do?
Well, if you do that, distribute the 3.
Yeah, so we could actually do it in any order. We could distribute this 3 first and then multiply by another 3, or I could multiply these 3's together and then distribute a 9. Yeah, I think I agree. I think, at least for me, that might be a little bit easier. We multiply that 3 and 3 and get 9, so this would be 9 times 3p plus 4 over, and then I can, again, I don't have to write all this out. I can just say this is 3 times p times 3p plus 4 plus So then over here, I would have p times p minus 4 over 3p times 3p plus 4. So now I can multiply these out. And I could distribute this 9. So 9 times 3p would be 27p. 9 times 4, 36. And again, I don't have to multiply out the denominators. Then over here, what would I get?
E squared minus p.
E squared minus 4p over 3 times p times 3p plus 4. Now I have common denominators.
What'd you put minus?
P times negative 1.
Down to
Left.
down left.
Oh, that should be plus. Thank you. Now, I have common denominators, so I can add my numerators together. There's only one, the 27p and the negative 4p. Those are my only like terms. So this would end up being e squared. 27p minus 4p would be 23p plus 36 over 3 times p times 3p plus 4. Okay. So to answer your question from earlier, Station, this is about as lengthy and complicated as they're going to get. A lot of P, man. There are lots of P's on board. How I got? Wait, what? Oh, so I just took 6 over 2, so that's the same as 3 over 1. Shut up.